This is essentially problem 80 from OpenStax Physics Chapter 22, but I'm going to really just do whatever I want because it's awesome. So this is what we call a cyclotron, and it's a way to get charged particles up to high speeds, high energy particles. What could you do with a high energy particle? Well, you could crash it into another particle and find out what they're made of, things like that. So in this case, let's imagine that, actually I'm going to change this to a positive proton. So let's say I have a positively charged proton. How do I make that thing go faster? Well, I could apply a force in the direction of motion, and one way to do that is with a potential difference. So I'm going to take these two metal things, they're called D's, and I'm going to apply a potential across them, a voltage across them. That's going to make this electric field. That electric field is going to make the charge accelerate. So this charge is going to accelerate from here to there. Now, if I have a small voltage, even if 1,000 volts, I'm not going to get it going that fast. I want it to go faster. Well, one way would be to make it go through this thing again. So what we do is we take our D's, we apply a voltage, the charge accelerates. Now once it's in here, it's moving this way, QV is that way, B is this way, so it has a force that way, the magnetic force, and it's going to make it move in a circle. Remember, F equals QVB sine theta. Theta between, the angle between QV and B is 90, so that's 1. So we get the force is QVB. And that's going to make it move in a circular path. We've already done this, but let's do it again. So if I have QV is this way, FB is that way, it's going to move in a circle of radius r, where the net force is QVB, and that's equal to mv squared over r, where that is the centripetal acceleration. Okay, so that's what we have. Now, that's going to go up here, right here. And now it's going to go back down to this other D. But what I want to do in that time is to take my electric field and change the direction. That's why I have an alternating voltage source over here. Now the electric field's right here. My charge is going to again be accelerated across this gap. And now it's going to be in this D, and I want it to again make a circle and then accelerate. And that time it takes to make the circle, I want to change the direction of the field again. So I'm going to flip-flop that oscillation, the voltage across this thing, to time it just right so that every time it crosses through, it gets a boost, 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 and it keeps on speeding up forever. Now, every time it speeds up, it's going to move a larger velocity. It's going to move in a larger radius of circle, right? Because I can solve for the radius of the circle, but I don't want to do that right now. I can't cancel this, right? So as V increases, R increases because Q is constant, B is constant, mass is constant. So what we want to find is how long this takes, how long it takes to go in a whole circle. Let's just say the whole circular oscillation. So I have an object with a velocity V. I know that's my velocity V. I can get that. It's a radius r. Well, how long does it take to move around there? Well, I can say the velocity is the distance it travels, 2 pi r, that's the circumference of a circle, divided by the time it takes. We call that the period. So let's just solve for the period. Well, the period is going to be 2 pi r over v. That's just for any circle moving at a circular speed. And really, it's just that part right there. Now, I want to substitute in this. I want to solve this for v and substitute it in down there. So up here, I get v equals qb r over m, and I'm going to put that in over here. So I get 2 pi r, and then for v, I get qbr over v. The v's cancel, the r's cancel. Oh, the mass. Where'd the mass go? Mass is v, so the mass is up here. So I get the period of oscillation is 2 pi m over qb. Is that what they said in the problems they gave you that? 2 pi, yeah, I got it right. Okay, that's a thumbs up for me. I'm waiting for it. You guys need to be, The computer needs to be faster. But that's important, right? Because it says the time it takes to go around half the circle would just be pi m over qb, which does not depend on the radius of the orbit. It does not depend on the velocity. So I don't need to change its frequency of oscillation. The frequency of the source is just going to be 1 over t. So every time, if I want to set that based on the mass and the charge and the magnetic field, that's it. I just set it and forget it. It's going to keep going around there. Every time, if I switch that voltage according to that frequency, every time it crosses this is going to get a boost in the right direction. And you can get these things up to pretty high speed. And the awesome thing is that it's pretty easy to build. You need a magnetic field and a variable power supply. Alternating power supply, that's it. Cyclotron. Particle accelerator in a box. Or not in a box, in a D. The end.